So in this lesson, we are going to introduce ourselves to partial derivatives. We are going to learn how to determine the first order partial derivatives of functions of several variables. So given that we have a function z, which is a function of two independent variables, x and y. Now one would want to know how z changes when x is held constant and then y varies, and at other instances one will also want to know how z changes when this time y is held constant and then x varies. Now this brings the idea of partial derivatives of x and y. Now these partial derivatives are obtained by keeping one variable constant and then differentiating the function with respect to another variable. So given that we have a function f of xy, the partial derivative of f with respect to x is given by the limit as h approaches 0 of the function f of x plus h y minus f of xy all divided by h, and the partial derivative of the function with respect to y is also given as the limit as h approaches 0 of the function f of x y plus h minus f of xy all divided by h. So using limits, this is how to determine the first order partial derivatives of functions of several variables. So let's try some examples. Now using limits and an alternative method, determine the first order partial derivatives fx and then fy of f of xy equals 2x squared times y plus 5x plus 6y. So let's try to solve this example together. So here we have the function f of xy, and that is giving us 2x squared y plus 5x plus 6y. Here we are asked to find the first order partial derivatives fx and then fy of this function using limit and an alternative method. So A, using limits, how do we find the first order partial derivative fx? So fx is given by the limits as h approaches 0 of the function f of x plus h y minus f of xy all divided by h. So f of x plus hy means that wherever we see x in the original function, we are going to replace that by x plus h. So this is equal to the limit as h approaches 0 of, we have 2 times x plus h all square times y plus 5 times x plus h plus 6y, and then minus the original function f of xy. So that is 2x squared y plus 5x plus 6y all divided by h. Next we have the limit as h approaches 0 of, now let's multiply the outer values across. So better still, we are going to have 2 times this times y. Now we can expand this to have x times x, which is x squared, plus x times h, which is xh, plus h times x, that is also xh, and then you add the 2, you have 2xh. So this becomes 2xh, and then plus h times h, which is h squared. So we can expand this to have that. We multiply 2 by whatever we have here, and then by y. So we are going to have 2 times x squared, 2 times x squared, so 2x squared, and then times y, plus 2 times 2 will be 4, so 4 xh and then times y plus 2 times h square, so 2h square and then times y, and then plus 5 times x, which is 5x, 5 times h, 5h, plus 6y. And then you multiply -1 across, you have minus 2x square y minus 5x minus 6y, all divided by h. Next, we cancel out 2x square y minus 2x square y, 5x, negative 5x, 6y, negative 6y. So we have the limit as h approaches 0 of the function. Now we have 4xhy plus 2x square y plus 5y. So we can factor out h, so that we have 4xy plus 2hy plus 5 inside of the brackets, or divided by h. So h cancels out h. At this point you can do direct substitution of h. So we have 4xy plus 2 times 0 times y plus 5, and that is equal to 4xy plus 5. Therefore we say that fx, which is the first order partial derivative of the function with respect to x, is equal to 4xy plus 5. Now, using an alternative method, how do we find fx? So using an alternative method, we have fx to be equal to, now this is the original function, and then what we are going to do is we are going to find the derivative of this function, or the partial derivative of this function with respect to x. So we are going to keep y constant and then differentiate with respect to x. So we are going to differentiate term by term. So for 2x square y, we want to differentiate with respect to x. So when we differentiate 2x square, we are going to obtain 4x, and then because y is a constant, we just repeat y, plus we differentiate 5x with respect to x, we have 5, and then we differentiate 6y. Now because 6y is a constant, when you differentiate a constant you have 0, so we differentiate this with respect to x, and then we have 0. Therefore we have fx to be equal to 4xy plus 5. So using limits and an alternative method, we've been able to find fx, which is the first order partial derivative of the function with respect to x. Now let's move on as we find fy. So given the function f of x y to be equal to 2x square y plus 5x plus 6y, let's find the first order partial derivative of the function with respect to y. So that is given by the limit, that is using limits. Using limits, we have that to be equal to the limit as h approaches 0 of f of x comma y plus h minus f of xy, all divided by h. So this is going to be the limit as h approaches 0 of, now f of x y plus h means that wherever we see y in the original function, we are going to replace that by y plus h. So we are going to have 2x square and then times y plus h plus 5x plus 6 into bracket y plus h minus f of xy, which is the original function. So we have 2x square y plus 5x plus 6y, and then all divided by h. Now let's work out the numerator. So we have the limit as h approaches 0. Now let's multiply the outer values across. So we are going to have 2x squared times y plus 2x squared times h plus 5x plus 6y minus 6y plus 6h minus 2x squared y minus 5x minus 6y, all divided by h. So this is equal to the limit as h approaches 0. So this cancels out that, this also cancels out that, and then this also cancels out that. So we are left with 2x squared h plus 6h. So we factor out h. Inside of the bracket we have 2x squared plus 6, all divided by h. So h cancels out h, and then we can do direct substitution. We have this to be 2x squared plus 6. In fact, we don't have h inside of the final expression, so that is equal to 2x squared plus 6. Therefore we have fy to be equal to 2x squared plus 6. Now, using an alternative method, let's try to find fy. So fy is equal to, here we want to find the partial derivative of this function with respect to y, which means that we are going to keep x as constant. Now for 2x squared y, we are going to focus on y. We differentiate y with respect to y, and then that gives us 1. So 1 times 2x squared is 2x squared plus, we differentiate this is a constant, so it goes to 0, plus we differentiate 6y, and then we have 6. Therefore we have fy to be equal to 2x squared plus 6. And then you realize that the two expressions for fy are the same, and also same for fx. So basically this is how to use limits to find the first order partial derivatives, fx and then fy, and then we can as well do that using an alternative approach. Now let's take some more examples. So considering some more examples, we are going to find the first order partial derivatives of the following functions 1 and 2. So let's try these two together. So for 1, we have the function f of xy equals 6x cubed plus 3y squared plus 5x squared y at x equals 1 and y equals 0. So let's try to find the partial derivative, or better still, the first order partial derivative of the function with respect to x, and that is equal to, so we are going to differentiate term by term. Now for this term, we differentiate with respect to x, and then we have 3 times 6, that is 18, so 18x squared plus, now this is a constant, so we differentiate this, and then we have 0 plus, we differentiate 5x squared with respect to x, 2 times 5 is 10, and then we have 10x and then times y. Therefore we have fx equals 18x squared plus 10xy. So at x equals 1 and then y equals 0, we have fx to be equal to 18 times 1 square plus 10 times 1 times 0. So this goes to 0, and then we have fx to be equal to 18. So this is the value of fx at x equals 1 and then y equals 0. Now let's find fy. So for fy, we differentiate this function with respect to y. 6x cubed is a constant, it goes to 0, plus we differentiate 3y squared, we have 6y, plus for this term we differentiate y, we have 1, and then 1 times 5x squared is still 5x squared. Therefore we have fy to be equal to 6y plus 5x squared at x equals 1 and then y equals 0. We have fy to be equal to 6 times 0 plus 5 times 1 square, which is equal to 5. So we have fy to be equal to 5 at x equals 1 and then y equals 0. Now let's move on to the second example. So we have the function f of xy to be equal to cos 4 over x times e to the power x square y minus 5y cube. So first of all, let's find fx. So fx is equal to, now here we have the product of two functions, so we are going to take one. So let's say we take cos 4 over x and then we differentiate the other. We are going to differentiate this with respect to x. Now in differentiating an exponential function, we are going to focus on the exponent. We differentiate the exponent with respect to x. So x squared becomes 2x, so we have 2x, and then we are going to repeat y, which is a constant, minus, this is a constant, so when you differentiate this you have 0, so you basically keep 2xy, and then we multiply that by e to the power x squared y minus 5y cube. So when you have an exponential function, let's say y is equal to 2 times e to the power, let's say x squared, then if you want to find the derivative of this function with respect to x, you basically differentiate the exponent. You have 2x, and then you repeat what you have, so you have 2e to the power x squared, so this becomes 4x times e to the power x squared. So basically that is how to deal with exponential functions. So this happens to be the first part, so plus, now we are going to consider this function, that is e to the power x squared y minus 5y cube, and then we try to differentiate this with respect to x. So here we have cos 4 over x, so that can be represented as 4 times x to the power negative 1, so cos 4x to the power negative 1. So when you differentiate this with respect to x, then basically you want to differentiate what we have in the bracket, so that becomes negative 4x raised to the power negative 2, and then when you differentiate cos, you have negative sign, so negative sign of 4 over x. So here you have e to the power x squared y minus 5y cube being common to both terms, so that is going to be, we factor out e to the power x squared y minus 5y cube, and then we have into brackets we have 2xy cos 4 over x, and then plus, in the sense that negative becomes positive, so this becomes 4 over x squared sine 4 over x. So that is the expression for fx. Now let's move on to fy. So for fy, as usual, we are going to hold one function, so cos 4 over x, and then we differentiate the other with respect to y. So we are going to differentiate this with respect to y. We differentiate the exponent. When you differentiate y, you have 1, so 1 times x squared, that becomes x squared. Here you have negative 5y cube. When you differentiate this with respect to y, you have negative 15y squared, and then you repeat what you had, so e to the power x squared y minus 5y cube, plus, this time you hold e to the power x squared y minus 5y cube, and then you want to differentiate this with respect to y. Now this is a constant. When you differentiate that, you have 0, So this term goes to 0, and then you have fy equals e to the power x squared y minus 5y cubed times x squared minus 15y squared times cos 4 over x. Now let's move on as we take some more examples. So for example 3, we have the function f of xy equals 10x cubed plus 3y squared plus 6y, all exponents 100. So to find fx, we are going to use the shortcut chain rule method. So we are going to drop down 100. Notice that we are going to differentiate with respect to x. So we drop down the exponent, which is 100, and then we differentiate what we have in the bracket with respect to x. So derivative of 10x cubed with respect to x, that's going to be 30x squared. This is a constant, it goes to 0. This is also a constant, it goes to 0. And then we are going to repeat what we had. So that is 10x cubed plus 3y squared plus 6y, and then we are going to reduce the exponent by 1, so that is 99. Therefore we have fx equals 100 times 30, that is 3000, so 3000 x squared times 10x cubed plus 3y squared plus 6y, all exponent 99. So that is for fx. Let's move on to fy. Also for fy, for this same function, we are going to drop down the exponent. We differentiate this with respect to y. So this goes to 0. This is a constant. We differentiate this, we have 6y. We differentiate this, we have 6. We are going to repeat what we have, 10x cubed plus 3y squared plus 6y. We are going to reduce the exponent by 1. Finally, we have fy to be 100 times 6y plus 6, and then times 10x cubed plus 3y squared plus 6y, all exponent 99. Now let's move on to example 4. There we have the function f of xy equals the cubed root of x to the power 4 y to the power 2 plus 5x plus 2e to the power 3y. So for this, let's try to find fx and then fy. So for fx, first of all, let's try to represent this as, here we have the cube root of x exponent 4 y exponent 2, so we can represent this as x to the power 4 y to the power 2, all exponents 1 over 3, okay, plus 5x plus 2e to the power 3y. So for fx, applying the shortcut method for chain rule here, we are going to drop down the exponent 1 over 3. We differentiate what we have in the bracket with respect to x, so that becomes 4x cubed times y squared, and then we are going to repeat this same thing, that is x to the power 4 y to the power 2, and then we reduce the exponent by 1. So 1 over 3 minus 1 is negative 2 over 3. Negative 2 over 3. We differentiate this with respect to x. We have 5. We differentiate this. This is a constant. We have 0. So finally, we have, let's say we have fx equals, this becomes 4 over 3 x to the power 3 y to the power 2 times, so here we have negative 2 over 3, so that means that we are going to have times 1 over, this 3 suggests that we have the cubed root of whatever we have here, x to the power 4 y to the power 2 all square, and then plus 5. So that is fx. Now for fy, for this same function, we are going to use again the shortcut method for the chain rule. We are going to drop down 3, we differentiate what we have in the brackets with respect to y, so that becomes 2x to the power 4 times y, and then we have the same thing, that is x to the power 4 y square. We are going to reduce the exponent by 1, so negative 2 over 3, and then this is 0, and then plus, when you differentiate 3y with respect to y, you have 3, so 3 times 2 is 6, so we have 6 times e to the power 3y. So we can simplify this as we have 2 over 3 times x to the power 4 times y, and then 1 over the cubed root of x to the power 4 y to the power 2 all square, and then plus 6 e to the power 3y. So this is fy. Now let's move on as we solve example 5 and 6. So for example 5, we have the function f of xy that is equal to x minus 3y over 5x minus y. So for this function, we are going to use the quotient rule. So we are going to let the numerator be u and then the denominator be v. So to find fx, that is given by, we are going to have v the u dx minus u dv dx, all divided by v square. So we have the u dx to be equal to, so the numerator we are going to differentiate with respect to x. When you differentiate x, you have 1. When you differentiate negative 3y, it's a constant, so you have 0. So this is the u dx, and then for dv dx, that will also be equal to, we differentiate 5x, we have 5. This is a constant, it goes to 0. So this is also dv dx. Therefore we have fx equals, we have v to be 5x minus y, so 5x minus y times du dx, which is 1, and then minus u, which is x minus 3y, that's also times dv dx, which is 5, all divided by v square, 5x minus y all square. So we have fx equals, this becomes 5x minus y, and then here we have negative x times 5, so negative 5x, and then negative, negative, positive, so 3 times 5 is 15, so plus 15y, all divided by 5x minus y all square. So next we have fx equals, so 5x minus 5x goes to 0, negative 1 plus 15 is 14, so we have 14y divided by 5x minus y all square. So this is fx. Now for fy, For fy, we have fy also to be equal to, still using the quotient rule, that's going to be v du dy minus u dv dy all divided by v square. So we have du dy equal to, we differentiate this with respect to y. This is a constant, so it becomes 0. So when you differentiate -3y with respect to y, you have -3. So that is -3. And then for for dv dy, you also differentiate the denominator. This goes to 0, you have -1. So that becomes, we have v to be 5x minus y times du dy, which is -3, minus u, which is x minus 3y, times dv dy, which is -1, all divided by 5x minus y all square. Now this is equal to, we have -15x and then plus 3y. This is negative, that becomes positive x. This is negative, positive times negative, so -3y all divided by 5x minus y all square. This is equal to, so this cancels out this, we have -15x plus x, that is -14x all divided by 5x minus y all square. So this is fy. Now for question 6, we have f of x, y, z equals x sine y minus z. So f of x, y, z equals x sine y minus z. So here we have a function of 3 variables. So we are going to find fx, fy, and then fz. So for fx, we are going to differentiate this with respect to x. So using the product rule, we are going to hold x, and then we differentiate this with respect to x. Now this is a constant, so it goes to 0, plus we hold sine y minus z. We differentiate x with respect to x, we have 1. Therefore we have fx to be equal to sine y minus z. So this is fx. Now for fy, for the same function, we are going to hold x, we differentiate this with respect to y. Now when you differentiate y, you have 1, so that is 1 times, when you differentiate negative z, you have 0, so you have 1 times, when you differentiate sine, you have cos, so that becomes 1 cos into bracket y minus z, and then plus, we are going to hold sine y minus z. We differentiate x with respect to y, it is 0, okay, or this is a constant, so it goes to 0, and then you have fy to be equal to x cos y minus z. So that is fy. Now for fz, that is equal to, you hold x, you differentiate this with respect to z. When you differentiate negative z, you have -1, so -1 times, you differentiate sine, you have cos, so cos y minus z, and then this time plus sine y minus z. You differentiate x with respect to z, or this is a constant, so it goes to 0, so you have negative x cos y minus z, and that is for fz. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.